Could you say again?
How big is the repo in total? It's just like so it's quite slow. I'm only at 12%. So I
Okay.
started 4 or 5 minutes ago.
Yeah, so it's better to copy from the pen drive, I think. Would be faster.
The repository is also on the pen drive.
Yes, everything. Everything. Okay, so I think we can start. Hello, everyone. That's very cool that there is here so many people. Um, we are glad to stand here and get the opportunity to present our workshop for you. I think that the title of it is for everybody because data quality is everywhere in every project. So the first question to you, how many people, please raise a hand, how many people testing data or validate data, geodata in your project? Quite nice statistic. Many people. That's good. Who is doing it automatically via Python? Not so many people, but it is. Okay. All right. So yeah, together with me and Mateusz, I'm Michal Pilarski. We will try to share our experience in data validation, actually geodata validation. Um, so I believe most of you just download the proper files for today's workshops. So on the you can see the link on the screen. It's a GitLab repository. So the branch is workshop GeoPython 2024. And what you need actually from that repository, you need to um, download the whole folder and install PyCharm. You will not find a PyCharm installer there on that repository, but you can download it from the internet. If you would like to use another idle, you can. Also in the installers, you can find the Python proper version. It's 3.11.9. So please install this kind of version because we will also set up the virtual environment later. All the materials you can find on the repository, right? So yeah, that's the moment to type in the repository and just download it. Or if you've got your Git, you can just pull it from the repo.
Okay, so meanwhile, you are typing this in. Let me introduce myself. My name is Mateusz Adamczak. I have like 10 years of experience in IT industry. Last 8 years I've spent in Boeing, working on mobile apps for pilots and data processing for pilots. So I was very focused on data quality because it was kind of important. But in March this year, I decided to quit, and now I'm unemployed. I'm on so-called sabbatical leave. So I have like 3 months break already, and I plan to have another 3. But let's see how it works.
Yeah. I'm Michal Pilarski. I'm also working Boeing. It's not valid anymore. Now, I think will be okay. All right. So, do you copy the link? Everybody got it? Okay. Yes. So, that what Mateusz and me mentioned, that was our work, but we've got our hobbies. Mateusz,
Yeah,
please
so
start.
I'm actually making beer. Now that I have a lot of free time, I make a lot of it, like 100 liters a week, and support that beer to my family and friends.
Yeah, and I also like mushrooms, taking mushrooms, as you can see. Even if we don't have mushroom in the forest, I've got my own in my home. So, all right. So the main motivation. What do we actually need the data testing, validation? So the first case from our experience is that on what you can see on the screen. It's not a Pangea. It's not a supercontinent. It's Poland. So probably you can see the corrupted data, geospatial data here. Nobody tested this product, and they trying to sell it in the market in Poland. Of course, I bought it. I got one. So this is the first case why we need testing. Another case is related to the Windows XP. Maybe not all of you got the experience with that kind of Windows, but there is a tab time zone, and when you look on that map, everything is all right, yeah. But when we zoom in a bit, you can see next case regarding to Poland, the Great Polish Bay, yeah. Thank you, Bill Gates. When I say the crucial word, something is broken with it. Bill Gates. Main workshop takeaways for you today. So we will try to walk through all the testing process regarding to the geospatial data. We will integrate GeoPandas Python library with the PyTest. PyTest is the most, I think, popular now.
Yeah, there are 2 popular frameworks. Where one is called PyTest, the other one is called Robot, and like the most of the industry is using those 2. So, yeah.
And optionally, we will see how we will be with time the continuous testing with Jenkins. From the audience, who got the experience with Jenkins continuous integration? All right, some of you. Thanks. All right. So what is actually GeoData validation? Maybe someone from the audience would like to say, what is the GeoData validation, data testing? Do you have some opinion, some definition? Actually, yes, it is about it. It's about data quality, yeah, and geometry regarding to our data, because nobody in the project, not all of people got the geometry in the data, yeah. So yeah, this is it. And from the, do you have some definition, Mateusz, from your side?
Well, I would say that the data we are using is in expected format, basically, comparing actual data to expected.
Yeah. For the computer, from the technical point of view, it's a, assertion, actual versus expected. So this is it. What can we validate? Data structure mainly. So data format, you got, for example, GeoJSON, you've got shape files, Go packages, and other formats. We need to check the data size. Yeah. So columns and columns names and counts of columns. Also number of rows. That's important. We can check everything in one test via checking the checksum of the data. Data values, more detailed checks. So we can check mandatory fields, null, missing values, duplicates, so it is regarding that data is unique or not. Data types, for example, numeric, string, dates, range of values regarding to numeric and dates, actually, and lists. So we've got the possible options of the strings. Yeah. Numeric precision also, data distribution, so profiling data, so we can check outliers, histogram, variance of data. More complicated tests of attributes relationships. So let's imagine that you've got the two columns and this data between two columns are related somehow, and you can test it. Yeah. Also between tables. Yeah. You could check patterns in your strings, numeric dates via regular expressions. You can check technical fields, primary keys, and geometry accuracy. I think that's the very valuable test for our data. For example, you can check that every point is on the polygon. Very simple test. Yeah. Consistency, completeness, topology, all on the green on the list. We try to today make some tests. This kind of tests which are highlighted on green. Okay, so some intro to our project data. Mateusz, give us some details.
Yeah. So as you know, I have a lot of free time, so I decided to join an open source project. I did that via one particular foundation called Tech to the Rescue. This is their website, and they connected me with a non-profit organization called Green Silk Road, where I met a person called Hai Spor. I think I pronounce his name correctly, and he had an idea to create a map with organizations he is cooperating with. When he travels from India to the Netherlands, it takes him around 5 weeks. But on the way, he is stopping at various non-profit organizations and cooperates with them. He wanted to use a protocol called murmurations protocol. They have a batch importer for the data, and you can display a map with loaded data, and that software also makes a easy to use WordPress plugin. So they knew each other, so they wanted also to use that map. And our data is a set of press articles from a website called Vikalp Sangam, and they have a map of the articles on their website where you could read a little bit more if you are interested for let's say in that region. So they provided us a CSV file which is the quality of the data is not not well maintained, to be diplomatic. So I had to clean that and upload that to the batch importer, but we'll find a lot of mistakes there, which makes a perfect case for workshop on testing data.
Okay, so as I mentioned, we need idle PyCharm. We have chosen PyCharm for this workshop, and we need Python, of course. Yeah, so please install this proper version. PyTest we will install together via requirements .txt. Of course, another library is GeoPandas, which I mentioned. So GeoPandas is very specific for installation. You can install it via Anaconda platform, but there is a way to install it, these dependencies in proper order, and you can do it without the Anaconda platform. And Folium. Folium is a library where we can generate the interactive map in HTML. So we will use it for data visualization to better detect the data issue, only for that. All right. So mainly on today's project, on today's workshop, we'll test simple GeoData in table format. Actually, the data which Mateusz showed with few attributes. We will do some intro to PyCharm, PyTest, GeoPandas, design some test cases together based on requirements prepared earlier by us, perform some test cases which we designed, and report it, yeah, in a very transparent and clear form, pass and fail, actually.
And also a map to show what points are outside polygon,
yeah,
which is very nice way to see it.
Yeah, okay, so Jenkins is optional, so maybe we will, let's move to our PyCharm. So, okay, so hopefully you can see well this code because it's crucial. Okay, so, but not everything is, all right, now it's better. Okay, so let me close all tabs. So, firstly, please open the PyCharm. if you've got or your own idle, and open the folder geospatial data test. So then you can see our project structure. And what we need to do, we need to create virtual environment. So to do that, just open here in the bottom right corner, open the interpreter options and add new interpreter. And if you click it, you can see the option with virtual environment. So you can add new. This location could be as it is, and the base interpreter should be exactly the one from the installers. So if you install, let me show you. So this is this folder, and in installers you can find the Python 3.11.9. So so this is it. So now it's the time to do that for you. Let's say about 2 minutes. I think it should be set up in that time. All right. So do you have any questions? Maybe something is not clear how to set up the Python interpreter in the idle. All right. So let's do it. All right, if we've got our PyCharm and if we've got our Python interpreter set up, so then we need to install all the libraries in Python. So we need to click on the terminal here and open the Windows PowerShell. And what we need to do, of course, you need to see this venv here. If you got this, you are sure that you are working on proper interpreter. Yeah, so that's important. That's the indicator. Yeah. So what we need to do, we need to go to installers folder. So cd space installers, and just install the requirements. So you can see if we install minus a requirements txt, we just, I will show you how the requirements looks like. And really, it's important to do that in that way. The proper order is crucial here. So firstly, we install GDAL, then PyProj, then Fiona, Shapely, and GeoPandas. And it works. So probably you know this method. So you can see that all that files installers are stored on this folder not, so we are not downloading the libraries. Everything is in wheels. Yeah.
And by the way, if you use Mac or any other Linux terminal, you will just go pip install GeoPandas and it will work. Windows is quite problematic for that library.
And now should be this with microphone. But exists only in my case. All right. Yeah, with Mac it's easier. Okay, so these libraries are related to the GeoPandas. Then we install PyTest. PyTest the main library of PyTest and also the plugin. So PyTest got many plugins. For example, PyTest HTML. And this plugin is very important for us to generate the reports in HTML. Then some minor but still valuable for us libraries. It's Volume, R3, Matplotlib, and MapClassify. It's only for the volume to make this interactive maps in HTML. Okay, so let's type in pip install -r requirements.txt. Remember that we need to be in the installers, and when we click enter, it should be installed. Of course, I've got everything installed already, so that's why it's so fast. So you need to wait 1 minute, probably. Yeah. Okay. So let's try to do that. Maybe I zoom in a bit and highlight this. That's the good question. Of course, I need, for example, for GeoPandas, you can see CP 311 dash CP 311. So that's why before the workshop, I needed to download proper version of this wheel for this Python version 3.11. So on the repository, you can find. I didn't find for Python 3.12 the whole package of these libraries. So that's why we are using 3.11. That's important. That's why I recommend to you install exactly this Python version. Yeah. Of course, it's possible to install it from the internet, but not always it works. Yeah. So that's why. Okay, please raise a hand who is still downloading, installing these kind of libraries. All right.
So tell us about how did you find the order of those packages?
That's a good moment, I think. So I just copy it from the article, but the article you can find I will show you, got everything on the repo. So this article you can find here in links, in installers, and there is a GeoPandas installation, this one. That's the really important knowledge to get this link. Okay, let's open it. And this is it. The easy way for Windows. For Windows, actually.
Yeah, for Windows, exactly.
Yes, and here in this article, oh, I don't have a account. Let's try to open it with Google. Yeah, it's now I need to pay for the medium. So in the past, I just downloaded it was open for everybody. Yeah. So more or less, you've got this kind of image. Yeah, this is this is it. Yeah. Okay. All right. I think we got it. So we can move to the PyCharm. Let's close it. Okay, so installers, source data. So you got, now we will do some tests. I think it's a good moment. So you can just open student and test, and you can find actually two files. One is conftest.pyu, and one is PyTest ini. And this PyTest ini, this is configuration file of the PyTest. So here in documentation, of course, you can find more info. By here, for example, we can configure the path to generating our HTML report with these arguments, for example. And of course, you can establish the proper prefix for your test cases for Python files, Python function, or classes. So more you can find in the documentation. But here we've got the very default configuration. Okay, so next very important file is conftest. Conftest, it's a file where you store fixtures. Fixtures are very specific object in Python, in PyTest actually.
Yes, they actually provide input parameters for your tests. Without them, your testing code is much longer. You use them as arguments. We'll explain in a little moment how to use them, but they are very, very powerful. And you can store them in the test files, but it's better to store them here, so they would be available for your entire project.
So actually now we don't have any fixtures here in this conftest file, but what we've got, I think Mateusz, that's your favorite. It's metadata, yeah, metadata. So as you can see, the date time of test execution, designer, test type, whatever you want to put here to better track your test reports, you can store it here.
Yeah, and I love them so much because when our testing frameworks didn't work, like 9 of 10 times it was because of metadata. So yeah, they are my favorite, and I had to fix them every time.
That's true. All right, but of course, for workshop purpose, we just put this kind of metadata in that file. All right, so you can see two files, but where is this proper actually the general file of tests? So that's our exercise for this workshop. So we need to create it. So let's create the Python file. Let's click right on the test and create new Python file. Let's name it test. We need to start from the test because in PyTest ini we set up that the Python file should be named properly. So test underscore something. Let's say GeoData, data, and click OK. So we've got our empty file. We need to import some libraries. So pandas as PD. Also, we need to import GeoPandas as GPD. And this is I think good moment to check that you installed your GeoPandas properly. So when you hold the control, left control, and click on GeoPandas, you can see the init file of this package. So it is located in lib, side packages, GeoPandas. So we've got this. So you can try it to open this init Python file. All right. Okay, so next what we need is a PyTest. Then we need OS. And the last, but not least, very important, it's NumPy as NP. And that's all. So not so many libraries. Okay, so now we will create the first fixture and create the very first test. So you will see how the convention of the PyTest looks like, yeah? To test just spatial data. So to create fixture, we need to actually create the definition. So we'll create the fixture which we call actual data file path. Actual data file path. And and this definition will, this fixture, not a function, that the fixture will return for us the file path, yeah, to our source data. Okay, so file path, and now we need to look to the source data and copy the post-export absolute file path. So if you go to the source data, you can find the post-export CSV. Just click right on it and copy path reference. And you can copy absolute path. And when you copy it, let's put R here to treat it as a raw string. And just return it. Of course, very simple, as you can see, but it's still, as you can see, it's still a function. We need to make it as a fixture, we need to add a decorator. It's important. So let's add the PyTest decorator fixture. And here we need to define the scope. So this fixture will be triggered one per running the Python file. So we need to put module. There are some other scopes like function, so only for particular one test, or for whole test, it's module, it's session also, so you can trigger the fixture once per session. So one per class, I believe it is also, yeah?
There is also one per class. If you have a testing suite with multiple tests, you can create fixtures for only that test suite.
Okay, so we've got fixture. So this is only something which returning file path, nothing else. Okay, let's make a test. So that's the crucial moment. Okay, so let's create a test. Let's call it def test. And as you can see, it's still important with this prefix. So the name of the file is test underscore geo underscore data. And also tests need to have this kind of prefix, because in PyTest ini, we establish that Python files need to have this kind of convention. Yeah.
Yeah, and if we didn't specify that in that ini file, the default name is also test underscore, or just start with test. So you can change it here, but default behavior is also like that.
Okay, so let's test data format. Yeah, so our requirements will be testing data format, Only that exercise is very. This is introduction exercise for very simple tests. Okay, so test underscore, and data format. Yeah, or sorry, yeah, data format. Data format. So it's very important to uh, to define or make the proper name of this function of this test, because now if I got this test data format, everything is clear. So I think we don't have any comments here. So it's very important to name it correctly. Yeah. And because when we are writing a code, actually, we are not writing for the computer. We are not writing for me as a developer or tester. I'm writing for Mateusz. And Mateusz, if you sit here and see, hey, test data format, now I know everything what this testing is doing. Yeah.
Yeah, and there is another layer. The test names will be visible in the report. So somebody who is analyzing the results probably also wants that name to be very clear.
Mm-hmm. Yeah. Okay. So there are two guys, actual, expected. And testing data, it's a game between them, actual and expected. So let's define actual guy. Actual, it is actual, what is actually in our data? Yeah, this is actual.
Yeah.
Yeah. Okay, so let's gather the uh, the extension of that file. Yeah. So os path split split text split text. Yeah, that's the correct split text. And yeah, and now that's the moment we need to use the fixture. Yeah. So let's imagine that I just copy this name of the fixture here because I need to have it in the bracket. And then if I've got it in the bracket, I can just put it here. So this is generally our actual data file path. Yeah.
Yeah. So would there be a difference if we just call that function in the test? Well, probably no. But this mechanism of storing them in the conf tests allows us to use them in a more clear way.
Yeah, absolutely. You can say, hey, why do we need the fixture? We can just copy this file path, yeah, and just paste here, and just this file path use here, and I don't need actually fixtures, yeah. But sometimes, in many cases, we need actually the same object in many tests. So it's very valuable to keep it in the fixture. Fixtures could use another fixtures. So we are building the structure of our fixtures. So we can, for example, get a connection to the database, the session, then we connect to the database, then we can disconnect from this database. And we've got actually now 3 fixtures, which are very connected. Yeah.
Yeah, and also usually it is the case that fixtures grow very large and tests don't. Tests are always simple, and fixtures could provide you like data file or something like that, or fragment of the data file. So it's better to have them and use simple tests and complex fixtures.
Yeah. All right. So we've got our actual. Okay, so let's see what is in under expected. What do you think? What should be here? Exactly. Very good. CSV. And the last line of this test, assertion. So we need to evaluate somehow that actual is expected or not. Yeah. So let's put it actual expected. And this is raw Python, as you can see. Why do we like PyTest? Because it's a Python. It's so Pythonic. It's a framework, right? But everyone, when you are looking first time of it, you can. It's very easy to read it. Yeah, it's just a Python. Yeah. All right. And after assertion, we need to put some valuable, clear uh, um, message. Yeah, when we've got some error. So, any idea what we should put here if this test failed? The sentence for human being. What we should put here? Perfect. Wrong. Yes, wrong.
And
File type.
we could also like be more specific. The actual is this, and the expected is this. But this is okay.
Yeah, and look what appeared. Appeared a run button here. Probably you don't have it in your idle because you need to install. You need to install in the options in the settings. You need to install plugin, PyTest plugin. So in the plugins in the marketplace, you can type in PyTest, and you can see the better PyTest, this plugin. So you can click it and install it, and then you should see the run button here. Because we've got list of tests in one file, so probably we would like to, for example, in developer mode, we would like to run only one test and see works or not. Yeah, for example, when we are writing this test. But more or less, we can run the whole file. Yeah. So when we go to the this kind of running, when you click right on it and click run, what will happen? It will create something like configuration in the PyTest. So you can see in this configuration of runners, in our runners, you've got, you can run actually the raw Python file, the script, what you've got, and you can run not this our file, test file, not as a Python file, but as a PyTest file. Yeah. So
And
via idle.
from the terminal, you need to use a command pytest and name of the file, and it should work.
Yes. So exactly when you, for example, make it clear. CLR? No. All right. So so we need to go to the main folder and go to the CD student uh, student test, and you can find test GeoData. And when we put PyTest test GeoData PY actually, so then you can trigger the PyTest file. Let's look on it. Yeah, it works. Yeah, when you so let's look on the what happened. So it opened test session. Then you can see all the libraries or plugins regarding to the PyTest. You can see metadata. This is everything what I establish in the conf test. Yeah. So this, yeah, platform, system version, and so on. You've got root dir. You've got config file. It's PyTest ini, and there is information about collected item. One item means one test in our test file. Yeah? And you can see the execution report that it passed.
And one recommendation here, it's kind of better to store your test in just one directory. Maybe change names of the files, but if you build a structure of directories and put your test in those directories, you can have problems with running those from the terminal. So it's better to have one directory. It might not look like very good, but it will save you a lot of time.
Okay, so let's make a false alarm. So let's make this test failed. Let's create a new data format, GeoCSV, in expected. It exists, something like that? I don't think so. GeoCSV, oh my God. All right, so GeoCSV. So of course, it's false alarm, but let's trigger the test again. Now, not via the terminal, but via just running our test here by PyCharm. Oh, it's failed. Look at what happened. So you can see that the assertion CSV it's not equal geo CSV, and you can see also the assertion error. It is somewhere or not? Yeah, it should be stored here, but it's not here. I don't know why. Should be stored in better. Maybe because should be stored somewhere here. Expected actual. I don't know where it's not stored here. Maybe it's
Probably in the report, so we can move on.
Yeah. Okay. So as you can see, you can see on the left panel also test results, test geodata, and test data format. So you can see all the tests in this file, yeah, and the performance of it. Of course, you can find additional two files, these reports generated by this plugin. So PyTest reports HTML. So when you open it, you need to open it via browser. So I think this is not so developer report. So you can see the environment, so all the metadata here, and you can see the statistics of one failed, 0 passed, and some another statuses. And here it's this assertion error, yeah, and this assert. So it's very nice to see, yeah. That
By default, you will see only the failed cases because that's the ones that you are probably more interested in. If they pass, they just pass, and well, let's move on.
Yeah. Yeah, we've got 1 hour almost. 5-minute breaks. 5-minute break. Do you need a break? Who needs? Oh, it's so easy that you don't need that. Okay, so let's move on. Yeah. So what I'm actually here returning, I'm returning that. When you okay, let's move it. Oh, sorry. Let's run it in debug mode. This kind of test. As you can see now in file path, you've got this string. Yeah. So this is it. Then I move to my test, and actual I just prepare the last characters only. If you want to prepare your fixture that returning the final .csv, it could be in that way. Yeah. Yes, this fixture, this kind of function, or this kind of split text. Yes, when you so this scope is very important because when I need this fixture for another test, I just import it because this in another test, actually this kind of fixture in the bracket. And you can reuse it for another test. Let's imagine that you would like to, that would be a dummy test, that drive is correct, C. So you can just, split the text correctly to C, and you've got your actual value to assert with expected. Yeah, module here is important because it will be triggered only once. When I will, for example, put it function, this fixture will be triggered many times, every time when you use it in the test. So when I add another second test in a scope function, I will just trigger it twice. It is not not good for performance. These scopes are for performance.
Yeah, so why would you need to call something only once? Let's say you are loading a lot of data from the database, and you want to perform it for only for not only one test but for many of them. Then you put module here, and the fixture loads it only once.
Exactly. So yeah, so we are in expect, so you can see actual, you can see GeoCSV, and when I click this, it's the last step. All right, easy, right? Creating tests in PyTest is easy. Okay, so let's move on to the another test. Okay, so let's create fixture which import our data. So what I need, I just copy. Let's maybe drop it. I just copy the header of the previous fixture. Change only the name of new one. So actual data. Actual data. That's the proper name of it. Yeah. Okay. And this
but maybe
fixture,
you will load that in some specific format. You could be more specific.
In a specific format. What do you mean?
Data frame, maybe?
Yes. Actually, yeah, we will try to do that. Okay, so what I need for actual data, I need to use the previous fixture. So so not only tests are using the fixtures, but also fixtures are using fixtures.
And by the way, usually this is a bad idea to provide arguments to fixtures. Define stuff you need there, and then don't use arguments. It will be easier for you.
Yeah. Okay. So let's create a data frame in pandas via pandas. So what I need, I just need actual data path and read the CSV. Let's replace the none by none. So df replace np none. Next, we will create a GeoData frame. So df GeoData frame and df geometry will be. I think that's a good moment to show you the data, how it looks like. Maybe let's open it in another editor.
So there are about more than 2,000 articles here, and as you can see, the encoding of the titles is somewhat cryptic. It's in a language I don't understand. In alphabet, I don't understand, and that causes a lot of problems for the batch loader in the murmurations protocol. So usually I had to filter them out to load them, and but some of them works. I didn't know how to change that.
Yeah. All right. So let's look on our attributes. Okay, latitude and longitude. As you can see, we've got some missed data here. And this is the format. So longitude is decimal degrees format. Latitude is the same, yeah, but we've got some missed data. So actually we will focus on these two columns, yeah. All right. Okay, so geometry. So we need to use GeoPandas points from XU and
Hints.
I got hints.
Hints.
Okay.
There's a typo.
Yeah. Hints. Yeah, I see. Yeah. So longitude. Guys, you are testers now, so if I got some mistakes on the screen, just ping me. All right. It's also testing. All right. Good. Okay. So we've got our geodata frame. And what is important also in our geospatial data? We've got geometry, we've got frame, geodata frame, but one of the attributes also is important. CRS. Very good. CRS.
And
so
by the way, this murmurations protocol doesn't note anything about the CRS. So we assumed it's WGS84, but we weren't sure. But it worked. So no information about that. It was well, let's say, shocking to me that somebody doesn't know the CRS of their data.
Yes, and we just return it. Of course, we can. I just copy it. You can paste it. We can. This fixture just return geodata frame with this data. Additionally, we can save this data to GeoJSON. We need to add the driver GeoJSON to our folder target data. Actually, it is here. Okay. So we have our data, our fixture with data. So now it's only the very happy moment to prepare only tests, because preparing fixtures, I think this is the most crucial, but I think it's more funny to prepare tests itself, yeah?
Yeah, just copy and paste.
Okay. What is also what we can add here? We can make a structure of this our test. So let's imagine that we got test cases, many of them, but we can group it together in a class. It's like actually the proper name for it. It's a test suite. So test suite is a group of test cases. Yeah. So it's, of course, it's a raw Python, so it's a class. Okay, so test data, for example, yeah, test data. And actually, we need to, oh my God, sorry. We need to add here static method. And okay, so let's create our next text, next test. It will be connected with columns number. Okay, so let's create it. So def, oh, should be static method also added. Yeah, it's copy paste. Okay, so test data columns number. What I need to put here? Actual data, of course. Because I need to then use self in the bracket, and it is easier to use static method.
I'm not actually sure why, but we kind of established that very early in our testing careers, and we just do it. But we kind of forgot why.
Yeah, because you can totally avoid that static method, and you can put self as the first parameter here. It will work, but it's better to avoid self because it's not object-oriented programming actually here. The class, yeah, but it's only for make the structure of data as a test suite, not for the as a class itself. It's only for as a grouping our test.
Yeah,
only for that.
we create a we create a class, but we kind of won't be creating object. We are using PyTest to do that for us. So it's just grouping mechanism.
Because when we run it in our test report, we got very well folder tree or this test suite tree only for that purpose. Yeah. All right. So yeah, actual. So actual. Actual data and columns, number of columns will be shape, and it will be this first index. Yeah. So expected. Of course, we need to check how to establish expected. Of course, from requirements, right? We don't have. Okay, so we don't have the requirements, but we are testing something. Okay, so what I should put here? Any idea? The message of failed test. Wrong columns number. Yeah, something like that. Yeah, wrong columns number. That's it. Let's run it. Oh, something is. Oh, I know what. I need to close this one and run it again. Something is wrong. Oh,
Yeah,
it's okay.
you didn't fix the.
Yes, there's noticeable. Who knows where is the problem?
You. Yeah.
What we would like to change? GDF here on GPD or change here? This one? Makes sense. All right. So as you can see, it's passed because it's 17, so it's good. Yeah, your previous question, test data. So you can see this class here. So you can easily expand this suite only for that. Yeah. Let's look on the PyTest report HTML. Also here. So this is the convention in PyTest that this is separated by double colon, right? Here you can see the double colon, the module name, the test suite, and the test case. So this is the proper structure of test in PyTest. All right, so one failed, one passed. Everything looks good. Yeah. Okay. So now it's your turn. Create now, please, exactly the same test, but for number of rows. So copy this previous test, this one, make some changes, and create requirements. It's test for rows number. Yeah, you've got, I don't know, 2 minutes. I think it's quite easy. So just copy it, and that's your time to do that, yeah, by your own here. Test
What's
data.
the expected number?
I don't know. Okay, expected here should be, let me check. 2221. Okay? Okay, so probably you know that we need to just change this 1 to 0 and wrong rows number. Pass or failed? failed because, yeah, should be 2. Should be 2, that's true. Okay, so this is it. Okay, so this is the main test of the data structure, yeah? But let's prepare some other tests regarding to the value inside the column, inside our GeoData frame. So maybe let's prepare another test suite, test data attributes. And let's create test case. So our requirement here for next one will be create the test case which will check the nulls in our column. Okay, so checking nulls. Okay, so name of the test will be test underscore data attribute latitude not nulls. Is this name of this test descriptive for you? If you don't have any comment here, let's imagine we don't have this comment. Test data attribute latitude, not nulls. Maybe it's not, but I think maybe we should add some comments. But if you find a proper way of this naming convention and everybody in your team know this naming convention of these test cases, I think it is quite good, yeah, to read it. Okay, so we need to create a empty list with log errors. So empty list, and now the loop for row in zip actual data index actual data ID, because we've got this kind of good indicator of the row. And actual data latitude. So this is our attribute, yeah? Latitude. Okay. And what we need? Row ID, variable, row ID, row 0, because this is the first of the zip list. ID is actually the unique ID, and actual value, actual value, and it is row 2. And the proper assertion is now. So if actual value is known, so if we've got this known, yeah, because we just replace the none to known, log error for us, yeah, so log errors, and append to this empty list. And now we are creating a really readable log. So f string and row ID row ID. Of course, convention is flexible. Pipe sign is, I think, okay here. ID must be ID, and actual is,
You got out of the string, so could look like this.
oh my god, here. Actual, no, it's okay. Actual value pipe expected. And this message is quite weird because it's not known. Expected, not known, because our requirement is this field should be populated. Yeah, shouldn't be missing. Okay, not known, and probably that's all. Okay, and look at that. So we just populate the empty list with this logs, but and assertion is very specific here because we'll just assert that our log errors should be empty. Yeah, so len of the list should be 0. Yeah, and then test will pass. If not, we just fail this test and log everything what is wrong. Okay, so very valuable information also here is errors log number. So we would like to know how many log we've got. So len log errors here, and to see it quite well we need to go to the next line plus, and on the next line we just print all the log errors. It is list, so we need to change it to the string. So n join log errors. Make sense? Now maybe it's complicated, but you will see the proper log. Yeah. Okay.
So we do it because if we have an assertion, we'll only find the first one. And with this approach, we are finding all the missing values, and that's more, well, that tells us more about the entire data set and not only if something goes wrong with the first record.
51, and you are a very good tester right now. That's true. Okay. Okay, so please remember that assert should be under for loop, not inside. Yeah, it's important. Okay. Okay, so let's run this test. Click play and open our HTML report. Oh, and let's maybe hide this one. Okay. Oh, and this is this test, not nulls. As you can see, in assertional error, you can see error log number 602, and actually you've got everything what you need to check your data, yeah, in your table. So we can see that first row, 0, with this ID, actual is known, expected, not known. And you've got every single row which is not correct. Yeah, make sense? Is it clear for you? Actually, I think this is a testing for latitude. Yeah. All right. So if we got this, let's move to the another one. Let's move to the another one, and let's now test data geometry. So I think also you can do you, if you know GeoPandas, I think you can create this test by your own. So let's just only test CRS. So def test underscore data CRS. So we need import actual data. Oh, sorry. And yeah, actual, expected. We established expected earlier, right? So we establish here. So we can copy it here. We just put it here. And yeah, assertion. Of course, assertion is actually the same as previous one with another message. Wrong. CRS. You could be more specific. For example, wrong CRS should be EPSG and the number, yeah, for example. Okay, so actual, do you know how to gather actual CRS from the GeoData frame? Actual data dot, no hints. That's GeoPandas or PyCharm. I don't know what. We should get some hint here. All right, so it should be CRS, and we just make a string. CRS. Oh, let's make failed test. Okay, just run it, and yeah, it's failed. Okay, so rest of all of the data data attributes, for example, geometry type, polygon points, multi-lines, you can check here. You can check also the extension of the data. Yeah, it is also, you can also gather it from the GeoData frame, yeah, in the attributes. So everything what you want to test. But I think now we will try to test the dependency. I mean the polygons. What I mentioned. The test will check if all points um, um, are placed on the polygon. So let's make this kind of test together. How to do that? Of course, we just integrate the GeoPandas and the PyTest. Okay, so static method, and the test will be test data inside country. I know, terrible name, but it is. Okay, so mainly we need to integrate the GeoPandas method. So is covered, and will be something like that. country data. I will show you how to gather the proper layers, because these layers must be dissolved. So we just import the layer with the lens, yeah, and we use our as a polygons, and we use points as our from our data. So dissolved covers actual data, and this data should be also dissolved. Dissolved means that there's multi-points or multi-polygons, yeah? So dissolved. Okay. Yeah, so this method, GeoPanda covers, just return false or true. So this variable got false or true, yeah? Is covered or not covered, yeah? Okay. And assert is covered. Actual data are outside country. But we don't have that guy because we don't have this fixture, and that guy still. So how to do that? How to speed up? We just go now to our folder tests. Here you've got in this test geodata in that kind of folder, you got prepared all the tests which we prepared and more. So when we open this test geodata in folder tests, we can actually copy the dissolved fixtures from line 24 to line 36. When we copy that to our student test as a fixture, so we need to put it in the fixture, actually here, somewhere here. Yeah, so we got it. Actual data dissolved and country data dissolved, these both. Yeah, so you can find it here. Yeah. Okay, so if we've got this, we have to also upgrade this test. You've got it here at the very bottom in this test. So we need to copy these two lines, and these two lines create GeoJSON, which is actually visualization of these points, which is not on the polygon, covered by polygon. So we are doing overlay of actual data and country, do the symmetric difference, and just put this geodata frame to the GeoJSON with driver GeoJSON. So actually these two lines we can also copy to our test. Still we've got some error, I don't know why. Let me see what is wrong. Fixture, country data dissolve, fixture. Should be okay. Country data dissolve. Maybe some typo, I don't know. is PyCharm error, I think. Yeah. Okay, so let's run it, yeah? We'll see. I will, it will tell me nothing, I believe. Okay, so as you can see, this test data inside country failed. Oh, no, it's something with the data. Let me see that assert discovered. That is solved. Okay, let's run this guy. Here is in this file in the test, not in the student. It works. So we've got some error. I don't know where. Let me look. Country data dissolved. Could you say again? Okay, so let me compare with show. In your test student. Could I hire you to my company? All right, thank you. Yeah, I think it will help this one, right? Should be. Okay, let's run it again. Which one? This one. Run. Okay, and it's, yeah, assert false. So it's failed. So, but I don't know where is the problem, yeah? Actually, which points are not on the polygon. So actually I need to create a map, yeah? And this is the volume is very useful here. So you can find the volume map creator. This volume map creator will create for us a map based on actually the our out.json, so actual data, the countries where you got shapefile with the lands on the whole world, and here we create some diff. So this diff is this difference. So when we create a map in volume, we just make some styles, symbology. So for example, for countries is green, for our actual data black, red is diff. We just add some legend, categorical legend, diff out countries, exactly the same colors. We got add some base maps, north arrow. It's important, Mateusz, right? To add north arrow and legend and so on, and add mouse position coordinates. Now I don't want to go through all that code because you can find in the documentation how to create this interactive map. But if you trigger this volume map creator, when you trigger it, it will create a map HTML file for you. Come on. Yeah, exit code 0. So this volume map creator, you just run as a Python script, not like a PyTest, but raw Python. Yeah. Okay, let's look on the map HTML. Open it. It's generated in general root folder. Let me open it here. That's it. So we've got our north arrow. Yeah, we've got our coordinates lon lat with mouse pointer. We've got scale. We've got legend here. It's leaflet, and we've got some countries. Yeah, this is this layer out. So this is our points. Let's zoom it a bit. And we've got our diff, so red points. So let's look on our problems. Where points it's not on the, so here maybe on the C, but let's see on another here. So where is the problem actually? Not in the tests, not in the data, actual data, but because these black points are okay. The reference layer of the lens. So this is actually what we called in testing a false alarm. Yeah, everything is good with our data because it is on the land here. Yeah, but the reference layer, the polygon, is corrupted or it is not created, not so precise built or generated. Yeah.
Yeah, and that's actually the real life example from our job. A friend of ours who coded that test worked like for a week and didn't know what happened. He thought he's doing some mistake in programming, but he actually found a point that was on a between two polygons, and actually he thought that that's his problem, but the problem was with the data then, and here the problem is with the the expected data.
Yeah, and even if you've got your automated tests in PyTest or whatever, you as a tester, you need to check this automation, yeah, because it could be this kind of case, yeah. Everything is okay with the data, yeah, but the problem is in environment, yeah, some in configuration or in the reference, yeah.
Yeah, and the question is why to automate in the first place? Because if you have to do something exactly once, like don't write PyTest test, just do check it yourself. But if you have a inflow of files, like I don't know, few a day or few a month, then it's worth it to write those tests. So you would know the problems earlier, because before you start to work with the data, and that's the main reason for us that we choose to automate that testing data.
All right. So that was all. That was some examples from us for you. I think you should be inspired to create your own test for your data in your way, in your convention, your framework, whatever you want to do. That's the template. Yeah, that's the approach which we propose for you, and how we should make it totally automated. We could apply Jenkins as a tool where we can run this test not on our in PyCharm in our local machine, but on another testing environment. Yeah. So Jenkins mainly is a CI/CD tool, continuous integration tool, where when we build a software or the data or a maps, then we need to test it, yeah, then before release it or deploy it in another system, yeah. So we can build in the Jenkins, and all right, so I will show you how it looks like. Exactly this the job. So this is Jenkins dashboard. When we go to our test geodata and configure how to configure it. So mainly we should run it from we should create in workspace. So download the current repository, like this repository with current our test. So we need to download the proper version. So we are starting from the Git. And when we've got our test in the workspace, we can trigger it. And we can trigger it very simple way. So I just replace the Git with just copy this my folder geodata to the proper workspace in Jenkins. So that's why it should be Git here. And then we just go to the scripts, to the proper Python interpreter, and run this PyTest and run our PyTest file. And that's it, yeah.
Please also tell us about the triggers, because there are multiple ways of running them. One is on demand, but maybe tell us about the time trigger.
Yeah, in Jenkins, actually you can build, of course, your job with parameters. This is one of the options, but you can schedule build periodically. So you can just use the cron, yeah, convention, and put the proper, as you can see, proper string, and just run your test nightly, for example, yeah, after your work. Nobody works on the test framework and on the developer system. Just run it, and at the next day we can check the reports actually. Yeah. So this is the proper way to set up it.
We had like a TV in our office where when we went to work, we could see that something failed because big red TV screen was showing, and it was hard to miss. So then we started our job by fixing everything that was broken.
It's very good, nice. Jenkins got many plugins, and you've got something like Take Test Result Analyzer. When you install it, when you integrate the PyTest with this kind of plugin, you can see every job, Jenkins job, with the status. Yeah, so we can see our data here. So we can see test data columns, test suite with the columns number, data format. You can see our data attributes tests which failed. You can click it to see the why it's, or you can see all the logs which we saw in the PyCharm, yeah, for example. So that's also very nice to see that. You've got some charts with passed, failed, some pie charts, some statistics. So yeah, that's very nice. All right. To summarize, I think congrats that you got your code in the PyCharm, in Python, in your PyTest, and you run it, and you create this volume map. I think that will be inspiration for you to use it. Make your geodata better quality. And I think that's a good time for some questions from your side. Of course, we are on the floor with Mateusz, so just ask us even after this meeting, yeah. So, but if you've got some questions, I think it's a good moment. Oh, remember, create a north arrow on your maps and legend. That's important, yeah. Okay, so if you don't
So thank you.
Thank you.